So let's talk about actual object orientation in Ruby. And I've kept saying this mantra, everything is an object, everything is a method call, Ruby's a dynamic language. So the question is, why should you actually care about this? How does it actually simplify object-oriented programming? So let's look at a simple example to walk through. I'm going to define a savings account, and hypothetically I'm going to say that it inherits from an existing class called account, although we don't have an existing class, so I just wanted to show you the syntax for inheritance. Of course I need a constructor, and in Ruby the constructor for a class by default is called initialize. Why is it called initialize but you call it with new? It's just the way the world is. Sorry, kids. What is this initializer going to do? It's going to take one argument, which is the initial balance. And note that because I've given the argument an optional value or a default value in the function definition, I can actually call the new function with no arguments and balance will default to 0. So you can have optional arguments with default values in Ruby as well. And when I call the constructor, it's going to take the balance that I passed in and assign it to an instance variable. Long ago, in the previous lecture, we said that instance variables begin with a single @ sign. So @balance is an instance variable, not to be confused with just plain balance, no @ sign. That's just a plain old local variable that disappears once we're no longer in the scope of the function. So that's the only thing the constructor does. And now we have a local variable or an instance variable in Java terminology to track the value of our account balance. But of course, we need to be able to get access to that. And unlike Java and some other languages, there's no notion of a public attribute. This instance variable @balance is visible only from within this specific instance of the object. So if somebody outside the object, and certainly outside of the class, wants to get access to that information, you have to define an accessor for it. So here's my simple accessor. Wow, I hope you got that. All it does is return, and by the way, in Ruby functions, if there's no explicit return statement, the value of the last expression evaluated in the function is the return value. Everything has a return value, and if you don't say return, what you get is the last expression evaluated. So there's my really simple accessor, or getter if you prefer. I also need a way maybe to set the balance. Who knows? Maybe I'd like to launder money into my bank account. So here's another function. And yes, balance equals is the name of a method. Remember I said everything is a method call? This is where we're starting to get serious. Okay, so balance equals is a different method from balance. There's a special case in Ruby for methods that end in the equal sign, and that's how you can define your own setters. So balance equals will take a new amount, and it'll just set the instance variable to that. Of course, real bank accounts are not quite this easy to add money to yourself, so we'll get more realistic in a moment. We can also deposit. That's easy enough. We just add the deposit amount onto the instance variable balance. We can also have class variables. Something like the name of the bank might be a variable that is independent of any particular instance, and we get those with the double @ sign. Again, class variables are accessible from within the class. If we wanted to have access to that variable from outside the class, we would have to define a specific getter for it. And here would be an example of that getter. Notice the difference in how we define it. We define self.bankname. The reason this works, and this is going to take a little bit of getting used to, is because once we've started this declaration class, inside of this declaration, the value of self is the new class being created. So if we say def self.someMethodName, what we're really saying is we're defining this method on the class itself, as opposed to these methods which are being defined on an instance of the class. Right on? And we'll just return the bank name. Notice that we're not providing a setter for the bank name class variable, so you can't set it. And an alternative to saying self.bankname is we could also put the name of the class.bankname. Why is that? Because inside of a class definition, the value of self is exactly the new class that you're in the process of creating. And that's the end of our class definition. Now in a moment, I'm going to fire up the Ruby interpreter so that we can actually try these examples live in real life. But before we do that, let's test your recollection here. Remember that I said, and remember, everything is an object, everything is a method call, a.b. Okay. Which ones of these are a correct way of getting access to the balance of a bank account instance? Let's do a quick initial vote. Quick initial vote.
Oh.
You guys are quick. You guys are quick. A sea of blue is what I see. Let's discuss the answer. So what's wrong with A? A volunteer from the audience. What is manifestly wrong with A?
You can't directly access private.
So that the one possibility is you can't directly access at balance, and while that is true, there's an even more superficial reason why the first one's wrong, sir.
There's no method called at balance.
There is no method called at balance. A.B always means call method B on object A. Method names don't ever begin with an at sign. Only instance variable names can begin with an at sign. So on its face, A just doesn't work. It's not even syntactically legal. B and C are equivalent, except that one of them omits the optional parentheses around the method call to balance. And that's it. So back into our discussion. I am now going to actually take some code and paste it into the Ruby interpreter. OK. I also took the liberty of creating 3 accounts we can play with. My account with $1,000, Dave's with $5,000, and Bill Gates with a lot more than either of us. So we'll come back to that. So now you know instance variables. You know that you have to define explicit getters and setters on instance variables. On the other hand, the getters and setters that we defined are pretty darn trivial. And it would be nice, right? This, to me, as soon as you start seeing stuff like this, where you've read this method and now you know what's coming, this is a sign that the language isn't supporting you. So might there be a more concise way? If these accessors and setters are such a common case, shouldn't there be a way to support them that is a little more elegant? And indeed there is. Let me do that again. Old way, new way. I just made code disappear. Okay? So what is this magic @_accessor thing? It's not part of the language. It is just a regular old method call. And in a moment, we're going to start talking more about metaprogramming, which is code that defines and writes and runs new code at runtime. And one thing I said when I began introducing Ruby is I'm only going to talk about these highfalutin modern language features because I believe they help you write cleaner code that is easier to read and understand. This is an example. In fact, in the next homework assignment, one of the things you're going to do is you're going to essentially create your own more sophisticated version of @_accessor. But when you say @_accessor balance, what you're basically saying is, please create for me these 2 methods, a default getter and a default setter that just do the obvious thing. And you can figure out how it does it, right? I mean, if you had to print out the text of those 2 methods based on @_accessor, you could do it. The difference is in Ruby, pretty much, if you can print it out at runtime, you can also execute it at runtime. And that's very cool. So, a quick review of Ruby's distinguishing features that we've seen. First of all, it is object-oriented in the extreme. Even the lowliest integers are objects. There's really no such thing as attributes. There's instance variables, but you have to define explicit getters and setters because you have to get at them through methods. Everything is a method call. Usually the only thing you care about in a method call is whether the receiver responds to the method you're trying to send it. And we'll have a lot more to say about that in a moment when we shortly talk about duck typing. And we've talked about the fact that objects can have different types, but the variables that refer to those objects are not typed. And as we'll see, most of the expressions that we've seen are non-destructive. So we gave examples of like adding strings together, adding arrays together. We're going to see some functions that let you select and remove elements and rearrange arrays. In almost all cases, with a few exceptions that we'll identify, those functions don't modify the receiver. They return a new copy of an object. And that's part of Ruby's heritage as being functionally flavored from the functional programming community.